So if you look at these 5 terms, we have reflected ray, angle of reflection, angle of incidence, incident ray, and reflecting surface. So if we're looking at this rectangle and we're saying that our reflecting surface is something like a mirror, if we're thinking about labeling our parts, first off, this is probably our mirror, this rectangle shape right here. If you're thinking about this set of arrows being a light beam, so like a laser beam that's bouncing off your mirror, and one of the arrows has to be the reflected ray, is it going to be the one that's being shot at the mirror and pointed towards the mirror, or the one that's bouncing off the mirror? It's bouncing off the mirror. So we're going to label this as reflected ray. And remember, light goes in rays. Rays are when you have an endpoint and then it goes on forever in one direction. So your ray has to start somewhere, like in your laser pointer, and then it goes on forever in the other direction. So if we have our reflected ray, the only other ray we have is the incident ray, which has to be this one. So I'm going to label that one as incident ray. And then we have an angle of reflection and an angle of incidence. These symbols are what we're going to use to talk about those 2 angles. And that circle symbol is called theta. So if we're going to talk about this angle right here and that angle right there, which one do you think we're going to label as the angle of incidence? Do it. Which one do you think we're going to label as the angle of reflection? Do it. So this is going to be my theta I, and this is going to be my theta R, because it's on the reflected ray side, so it's the angle that the ray makes with the surface. And this is the incident ray. Incident is like incoming. That's the angle that the incoming laser beam light makes with the surface. You'll notice when we do our arrows on here, we put the arrows in the middle. We don't put them on the end because we want to be able to measure this angle, and if the arrow is right here on the end, it makes it harder to measure that angle. So what we're going to do is we're going to take our protractor, and remember, you always want to line up your angle right here at the T. So I'm going to line the point of the V up with the T, and I'm going to make sure that that dotted line right here is lined up with the 0 and 180 line. And then I'm going to measure. Now, here's my trouble. Does this line, and it's kind of hard to see by shadows, hang on, there's going to be a weird noise. Nope, that didn't make it better. I'll just put my head in front of it. There we go. So, you can't see the end of the angle on the tick marks. So what you have to do, and what we're going to have to do a lot in this section, is we're going to have to extend our angle line longer so that we can see it on all of the little tick marks. So the way you do that, the way I do it, is I put my pen or pencil on the line itself, and then I line my protractor up so it looks perfectly even with the line. And then I just draw it out. I'm going to have to do the same thing over here, so I'm going to put my pen on the line. I'm going to line the edge of my protractor up with it so it looks perfect, and then I'm going to draw it out. That way, both of these are going to come on the tiny tick marks. So I'm going to line this up with the T again. If we look at this side and we look at our tiny tick marks, we're counting on the outside tick marks because it starts at 0 over here. And we count up and we get to, hey, 45. So my angle of incidence is going to be 45 degrees. Measure your angle of reflection. So that's this angle right here. What do you notice? It's also 45. So your angle of incidence and your angle of reflection are both 45, so they relate to each other because they're always equal. Always equal. All right, so if we look at number 2, if we hold our protractor so that the T on the protractor right here lines up with the perfect side of the angle. Now we might want to make ourselves a note that when we're looking at our angles of reflection and our angles of incidence, we're always looking at the acute angle. Because we have to have one on the left and the right, if we have them obtuse, they would overlap. So we always want to look at those acute angles. So if I hold this up and I have the corner of my angle under there lining up with the T, and then the mirror lining up with my 0 and 180 line, you'll notice, again, my mirror, or my incident ray, doesn't touch my tiny tick marks. So again, I'm going to have to put my pen on the line, put my protractor against it, and extend that line out. And then when I measure it, again, we always want to start at 0. So this one starts at 0. It's between 40 and 50. So if we count this 140 as being my 40, I'm going to count my tick marks. I have 1, 2, 3, 4, 5, 6. It's between 6 and 7. My pen is pretty fat. If I line it up a little bit more carefully, I think it's 46. So I'm going to label this as 46. Now, it wants us to draw the reflected ray. The way you do that is you don't even have to move your protractor. So once you measure it and you see that it's 46 degrees, what you want to do is go to the other side of your protractor where it starts at 0 and go to 46 degrees. So I'm on the outside. Here's 45, here's 46, and I'm going to draw myself a dot. Because then I can take my protractor, I can use it like a straight edge, I can connect my dot with the tip of my incident ray and make myself a V. Again, you want to draw an arrow in the middle of it, not at the end, which is kind of weird, but remember if it's at the end it's hard to measure. And then I'm going to label this as 46 degrees as well. So this is your incident ray because it's going in towards the mirror. This is your reflected ray because it's being reflected off your mirror. So pause the video, try the next 2. What this one is asking you to do is it's saying that there is a light coming through this opening. It's directed at 2 mirrors. So this is a mirror, and this is a mirror. And then we want to see which of these 3 flowers will it hit. So the first step in order to solve this is, first off, we got to make this beam of light actually hit the mirror. So I'm going to use the edge of my protractor as my ruler. Again, I'm going to put my pen on the line itself. I'm going to line my protractor up so it looks perfect with that line. And then I'm going to draw it until it hits the mirror. It's not going to go past the mirror because, think about it, stuff doesn't go through the mirror. It's going to hit it. And then we're going to line this up, line the T up with where it hits the mirror. And we're going to measure the acute angle. The acute angle is going to be this side. Remember, acute is less than 90, so it's going to be this side. If I measure this angle, I start at 0. Look at that. It lines up with the line on my protractor at 60 degrees. So I'm going to label this as 60 degrees. And then you don't even have to move your protractor. You can label it later. Sorry if you had it perfectly lined up. Pro tip, don't move your protractor in between. Label it later. So you're going to go from your other side. You're going to go from 0. You're going to go all the way to 60. You're going to put yourself a dot. And then you're going to connect your V with that dot you just made until you hit mirror number 2. And then you can label all your 60s and stuff. We want to make sure we put an arrow on this ray for the direction it's going. So remember, it came out of the light. It went this way. It hit the mirror. It went this way. So then what I want you to do is measure this angle right here, because that's your angle of incidence. draw your angle of reflection out here and see which flower is it going to hit. When you're done with that, you can keep going with 4. 4 is just asking you to, these are incident rays, so these are incoming rays. They should have little arrows on them, so you can go ahead and draw the arrows. What I personally would do is I would highlight them in different colors. So I'm going to say that this is my pink one, and when I draw its ray of reflection, I'm going to highlight it in pink. This, for me, is going to be yellow, and when I draw its reflected ray, I'm going to highlight it in yellow, and this one's going to be blue. And you don't have to use the same colors, but it helps to color code them so you know which one's reflected ray is which. Once you're done with number 4, go to number 5. You'll notice this is an incident ray, so this is your incoming one. This is your reflected ray. These are not connected. These are like 2 separate problems on one mirror. So you're going to have a reflected ray off here, and you're going to have to figure out an incident ray, so go backwards off here. They're going to overlap. Then you're going to describe these in your own words, angle of incidence and angle of reflection. For number 7, you're going to have to draw a diagram that shows your mirror. So remember, to draw a mirror, it's just a straight line. And then draw an angle of incidence of 60 degrees and then reflect it. So you're drawing the whole thing this time. Number 8 is taking it a step beyond and saying that if light strikes the mirror, the angle between your incident ray and your reflected ray is 90 degrees. So it's saying this space right here is a right angle, and mine obviously isn't because I just sketched it, but then it's asking, what are these angles? What is your angle of incidence right here and your angle of reflection right here? This takes into account supplementary angles. It's like a linear pair, except with 3. Remember, a linear pair only has 2 angles. You don't have to write that. That's just here for your help. While you watch this video, you can go back and replay it while you're working on it. So let Ms. Stoner know if she's in this class, if you need help, and we're ready to rock and roll.